Hi all. Today I am going to explain about greedy method. Okay, this is one of the topic in DAA. DAA is nothing but a design and analysis of algorithm. Design and analysis of algorithms. Okay, today I am going to explain about greedy method. What is greedy method? Greedy method is nothing but it is used to solve optimization problems. At each and every step it will suggest or it will choose for the best option, but it won't think about the further step or future if it is we are getting the optimal solution or not. But starting itself, what we are doing at each and every step, we are picking the best solution which we are finding. So by using greedy method, we have 4 applications. The first one is job sequencing with deadlines. Job sequencing with deadlines. And the second topic is knapsack problem. The second topic is knapsack problem. And the third one is minimum cost spanning tree. Third one is minimum cost spanning tree. And the final one is single source shortest path. Single source shortest path. So here I am going to explain the brief description about these 4 applications in greedy method. What is the first one? Job sequencing with deadlines. Job sequencing is with deadlines is nothing but we are scheduling the jobs to a system based on their deadline. Deadline is nothing but the time limit in which it should be executed or it should be completed the task. And the second one is knapsack problem. Here knapsack is nothing but a bag. Okay, for example, if we are taking 4 quantities or 4 list of items, we need to place these items into the bag. These items into the bag. This is nothing but a knapsack problem. By using greedy method, we will find the best solution for knapsack problem. Here, we are not at all in previous problems like in dynamic programming. There we will place whether the item should be placed in that bag or not. But by using greedy method, here we can place the item in partitions also. Partitions also, or nothing but portions of that item. Okay, and the third one is minimum cost spanning tree. Here what is meant by a spanning tree? Spanning tree is nothing but we will consider a graph. Okay, we will consider a graph, original graph, where we will try to find a solution with the minimum cost. That is nothing but here for each and every graph, original graph, we are going to draw a spanning tree. Here spanning tree is nothing but we are considering the original graph. From that we are going to draw a spanning tree, whether if the graph consists of 4 vertices and 6 edges. Edges are nothing but connection between those vertices, and we will be having a connected or we will be having a directed graph or undirected graph. We are going to consider that graph, and with the help of this graph we are going to draw the spanning tree. For example, if I am going to draw a spanning tree for the graph with 4 vertices and 6 edges, what I will do, I'll consider all those 4 vertices. I will consider all those 4 vertices for drawing a spanning tree. But what is the main thing? If the original graph consists of 6 edges, we need to take only vertices minus 1. It is nothing but here we have 4 vertices, right? So when I am going to draw a spanning tree for the original graph, I need to do is 4 minus 1 is nothing but 3. So when I am going to draw a spanning tree, I should get only 3 edges. In that I need to find out whether it is a least cost spanning tree or not. Okay, and the final one is single source shortest path. Single source shortest path is nothing but we will be considering a graph. From that graph we will be considering one vertex as a source vertex. Okay, from that source vertex we need to find whether for traveling from one vertex to another vertex what is the cost. Okay, for example, see here I am considering first vertex from 2, 3, 4, 5 and 6, and the final one from 2 to 6. So I will consider one vertex as a source path. So from here I need to find the way to all the vertices and which will get the minimum cost or the least cost we will consider here. So today I am going to explain about minimum cost spanning tree in detail. Okay, today I am going to explain minimum cost spanning tree in detail. So what is a spanning tree? First we will consider what is a spanning tree. Spanning tree is nothing but a graph where will consist of vertices, edges. From each vertex we will be having path to the remaining vertices. Okay, from each vertex we will be having the path to the remaining vertices, and we will be having the path, nothing but the cost from one vertex to another vertex. We can call it as, whether we can call it as the like minimum cost, or this we can call it as cost or time, okay, or quantity. Okay, so what are the conditions here is this minimum cost spanning tree we can call it as MST or spanning tree with minimum cost. So what are the conditions to draw a minimum cost spanning tree, and what are the requirements to draw a minimum cost spanning tree? For example, today I am going to explain what are the use cases where we will use this spanning tree. Okay, so whenever we are going to label the cables, laying the cables underground, or whenever we are going to construct pipelines on roads. So what are the use cases here? We are searching for the minimum cost or the minimum way to labeling the cables or to construct the pipelines on roads underground way. Okay, so what we will do here is we will find the best minimum cost for doing these two works. Okay, but for drawing this minimum cost, first we need to know about spanning tree. So now I will tell about what is meant by a spanning tree and how to draw a spanning tree. Okay, later we will discuss what are the algorithms required to draw a minimum cost spanning tree and how we will get the minimum cost spanning tree in detail. Okay, so here I am taking one example. Here I am taking one example. I am taking 4 vertices. I am taking 4 vertices. Each edge will cost some cost, like from this second vertex to fourth vertex it will be 2, here 3, 5, 4 and 1. So I will explain now in detail how to draw a spanning tree. Here I am considering a small graph, okay, with 4 vertices and 5 edges, and each edge is having particular cost. Okay, so by seeing this we will know what is the initial condition here is, first how many number of vertices are there? 4 vertices. How many edges are there? 5 edges are there. But what is the condition to draw a spanning tree is we need to consider all the vertices. We need to consider all the vertices, but the edges should be p minus 1, nothing but 4 minus 1 is equals to 3. Okay, so now for drawing a spanning tree, how many vertices we require? 4. How many edges we require? Only 3. So now I will start doing. Okay, so what is the first initial step? We need to take all the vertices, but while considering the edges, we need to select the only how many edges? 3 edges. So all the possible conditions I will draw. What is the first possibility? I will draw one edge from 1 to 2, next 2 to 5, next 2 to 4. Okay, condition satisfied. I took all the vertices, number of edges are 3. Okay, what is the cost here? 5 plus 3 plus 2, it is 10, right? Next possibility. Okay, what is the next possibility? Now I will consider from 2 to 3 5, 3 to 4 1, and 1 to 4 4. What is the cost here? 5 plus 4 plus 1, cost is 10. Next I will search. Number of spanning trees will depend. Okay, we have 5 edges and 4 vertices. We can draw any number of spanning trees, but the condition is we need to get the minimum cost spanning tree from this. Okay, so now I will check for the minimum spanning tree. Okay, another possibility, from 3 to 4 1, and from 4 to 5 2, and the next possibility is 1 to 2. Here the cost is 6. Okay, and one more condition, when we are drawing a spanning tree, it should not form any loop. Okay, it should not form any loop. If it is going to form a cycle or a loop, we will ignore that vertex or we will ignore that edge. Okay, so we can draw many more spanning trees for this graph, but by comparing, we can say like this graph and these 3 graphs, we can directly say this is the minimum cost spanning tree. Okay, so when we are easily finding for with 4 vertices, we are easily going to find, and we are easily to draw also. How many number of conditions also we can draw. But if the graph consists of 8 vertices or 9 vertices or above that, okay, above that, we are unable to draw the spanning tree very easily, and we are not able to find the solution quickly. Okay, for this method, for this finding the minimum cost spanning tree in these conditions, we have 2 algorithms. Okay, we have 2 algorithms, and the first algorithm is for finding the minimum cost spanning tree. We have 2 algorithms. The first one is Prim's algorithm, and the second one is Kruskal's algorithm. Okay, now for finding the minimum cost spanning tree, in what conditions, if the number of vertices are more, we are unable to draw easily. In that condition, we are going to use these 2 algorithms. So with these algorithms, we are going to find the solution very easily. Okay, now I am going to explain you what is Prim's algorithm and Kruskal's algorithm in detail. Okay, if you know the method to draw a spanning tree, it is very easy to draw Kruskal's algorithm. By using Kruskal's and Prim's algorithm also we can draw easily. Okay, so I am going to explain it. Okay, next, see what I said. I am going to explain about Kruskal's algorithm and Prim's algorithm. Remember this, for drawing a minimum cost spanning tree, we have 2 algorithms. The first one is Prim's algorithm and the second one is Kruskal's algorithm. So here I am considering one example. Okay, here I am considering one example. This is nothing but a graph which consists of 7 vertices, and from each vertex we have edges connected, and for each edge we have a cost. Okay, so the same graph I'm going to take to draw using Kruskal's and Prim's algorithm. Okay, the first method I am going to use is Prim's algorithm. What is meant by Prim's algorithm? Okay, what is meant by Prim's algorithm? Okay, and what is meant by Kruskal's algorithm? Okay, what is meant by Prim's algorithm? So we need to draw a spanning tree starting with one vertex. The initial vertex we are considering here as 1. Okay, we need to start with an initial vertex and we need to start drawing the spanning tree. And what are the main condition here is, when we are drawing a edge from one vertex to another vertex, it should be connected, and we need to select the minimum cost edge within that connected graph. See, for example, here what is the minimum cost edge here? This is the minimum cost edge from 1 to 6. Okay, now I will start drawing for you by using Prim's algorithm. Okay, the minimum cost spanning tree from 1 to 6, the minimum cost edge starts. Okay, this is the minimum cost edge. So what is the second minimum cost edge? Here from 3 to 4, the minimum cost is 12. Okay, but what we need to do by using Prim's algorithm here is, 1 to 6 you have drawn the spanning tree, you have started, but when you are going to select the next edge, here the condition is we need to check with the connected graph, like from 1 to 2 and 6 to 5 only we need to pick. We need not to pick the least edge in the graph. Okay, you will be coming to know in detail when I am going to draw Kruskal's algorithm. We will be going to learn in detail. Okay, the clarification you will get. See, now I drawn from 1 to 6 the edge with the cost 10. Next edge I need to select, next vertex I need to select based on the cost. Here 25, here 28, which is the minimum one. This edge is the minimum one. So what I will do, I will connect from 6 to 5, the minimum cost is 25. Okay, next you compare from vertex 5 and vertex 1, which is having the minimum cost edge. See here we have 22, 24 and here we have 28. When comparing 22, 24 and 28, 22 is less, right? So I will select this edge 5 to 4. This is 22. Okay, next we will compare again from 4, vertex 4 and vertex 1, which is having least cost. Vertex 4 is having 12 and vertex 1 is having 28. So when comparing 12 and 28, 12 is lesser than 28, right? So I'm picking this vertex 3 with the cost 12. Okay, now next least cost edge we need to pick, right? So from 3, what is the next one? From 3 it is 16, right? And here 28. So when compare with 16 and 28, 16 is lesser. So what I will do, I will start with 3. Okay, I will pick this path and the cost is 16. Okay, so next vertex, what is the next remaining vertex? 7. But the cost is, when compared to 28 and 14, this is less cost, right? If you are picking 28, it will form a loop. So we need to ignore this edge. So from 2 to 7, this is the least cost. So I will pick this edge and the cost is 14. Understood? So when we are drawing a Prim's algorithm, always what we need to see is least cost edge with the connected vertex. Okay, so 1 to 2 and 1 to 6, 10 is lesser, so I picked this path. Okay, next from 6th vertex, when we are comparing from 6th vertex, 6th and here 25 and 28, 25 is lesser, so I picked this path. Next one, vertex 5. From vertex 5, 22 and 24. 22 is lesser. So we need to pick according to their weights, and it should be connected with the vertex. Okay. So now we will calculate the cost. What is the minimum cost? 10, 25, 22, 12, 14 and 16. Okay. What is the weight? Total minimum cost 20. Okay. This is about Prim's algorithm. What is Prim's algorithm? Whenever we are going to draw a spanning tree, it should be connected with the previous vertex, and according to their weights we need to pick the path. Okay. Now we will see about Kruskal's algorithm. Okay. Kruskal's algorithm. This is also used to find the minimum cost spanning tree. Okay. So I am considering the same graph to get a clear difference between the Prims and Kruskals. Okay. So what is the least cost? The vertex 1 to 6. This path is least. Okay. 1 to 6. The cost is 10. Okay. The next one. What is the next one? From path, from vertex 3 to 4. Okay. Now I think you will get a clear thing. The difference between the Prims and Kruskals is the Prims, it should be connected to the previous vertex. Okay. The previous vertex, it should be connected while selecting the minimum cost. But when we are coming to the Kruskal's algorithm, we need not to check whether it is having a connection between the previous vertex and the final vertex. Okay. Now what we are drawing, it should not be connected. No conditions are like that. Okay. So what is the next minimum cost? 7 to 2. Okay. The cost is 14. What is the next minimum cost? It is between second vertex and third vertex. The cost is 16. Okay. And the next minimum cost is 18 in that graph. But what is the condition? It should not form any cycle. Okay. It should not form any cycle. Here what? If we are considering this edge, it is forming a loop, right? So what we need to do? We need to ignore this edge. Okay. We need to ignore this edge. Whenever we are drawing a spanning tree, it should not form any loop. Okay. And here edge between 7th vertex and 4th vertex, it is making a loop. So we are ignoring that edge. Okay. We are ignoring that edge. What is the next one? 12, 10, 12, 14, 16 completed. 18 we ignored. What is the next one? Next least one is 22, right? The edge between 4 and 5. This is 22. Okay. After that, the minimum cost between these edges, minimum cost between these vertices, we will, when we are comparing, it is between 6 and 5, it is 25. Okay. Yes, 25. But when we compare 25 and 24, 24 is the least one. Okay. So what we will do? If we are drawing 24, what is the condition? It should not form any loop, right? So what is the condition? It should not form any loop. So we are ignoring this. Okay. When compared to 24 and 25, 24 is the least cost edge, but if we are considering that edge, it is forming a loop. So we will ignore that loop, that edge. So next one is 20. Okay. So this is the minimum cost spanning tree for this graph by using Kruskal's algorithm. Now what is the final point is, when we compare Prims and Kruskals, okay, first we will calculate the cost. 10, 25, 22, 12, 16 and 14. What is the cost? So the final comparison is, when we are going to draw by using Prim's algorithm or Kruskal's algorithm, the final thing is we will get the same spanning tree, same minimum cost spanning tree, but by using these both algorithms. Okay, so the cost is here 99 and here also 99. When you see the graph also, the spanning tree is also same. Okay, the final conclusion is, whenever we are going to draw a minimum cost spanning tree, we need to pick the minimum cost edge and it should not form any loop. Okay, it should not form any loop. For this minimum cost, for finding this minimum cost spanning tree, we have two algorithms. The first one is Prim's algorithm and the second one is Kruskal's algorithm. Why we are using these algorithms to to find the minimum cost spanning tree is, we can find manually. It is only when the vertices are only 4 or 5, when the count is less, we can find the spanning tree very easily manually. But it is going to exceed more than 7 or more than 9, 10. If the count of vertices are increasing, and the problem complexity will also increase, manually it is very difficult to calculate. Okay, for these things we have two algorithms, that is Prim's and Kruskal's. Thank you.